All right, so here we go. We're gonna work out the. I'm gonna do the first three, and then maybe some students will do the next three. But what we're gonna have to do is be able to convert an equation that's in standard form over to slope-intercept form, so that way we can graph it and compare the slope and all kinds of stuff like that. So number one, I'll take a little bit more time on number one, but they're all pretty much done the exact same. So if I've got 2x plus 2y equals 4. Now, I'm trying to get it into slope-intercept form, which is y equals mx plus b. So what I told my students is actually write y equals mx plus b above this equation, and that's going to help guide you on who needs to go away. Because what we're going to do is we're going to eliminate people that are on the wrong side. See, on this left side, I want only y's to be on this side. Everyone else goes on the other side. So you see this 2x right here, he's not a y, but he's sitting on the side that I want only y's to be on. So I need that 2x to go away. And you learned back in 7th grade that the way you make things go away is by using the inverse operation. And that basically means opposite operation. So the opposite of adding 2 x's is subtracting 2 x's. If I have 2 x's and I take 2 away, well then, there you go. I got no x's anymore. So because it's an equation, if I subtract 2 x's on this left side of the equation, I have to keep it balanced and subtract 2 x's from the right side of the equation. So whenever I do that and I rewrite my equation, I'm left with 2y on the left side. Let's see, getting an email. Alright, 2y on the left side equals negative 2x plus 4. Now let me explain this part. You also learned back in 7th grade that I cannot combine these two. And the reason why is because they are not like terms. These guys right here, they're numbers. These guys right here, they're variables. They're x variables. So they're not alike, so I have to keep them separate. And that's called like terms, which you learned in 7th grade. So the other thing that you may have noticed is I put my x's before I put my numbers. And let me explain why I did that. The reason I put my x's up front is because I want it in slope-intercept form. Y equals mx plus b. You see how my x stuff goes in front of my b right here? So that's why I'm putting it first. Alright, so now let's continue on. I've got 2y equals negative 2x plus 4. Now remember, I want just one y all by itself, so I need to get that 2 away. So you have to ask yourself, what is that 2 doing? Well, that's a multiplying 2. You learned back in about 5th or 6th grade that if a number is right up next to a variable, it means that they're multiplying. So I'm going to do the opposite of multiplying by 2, and that is dividing by 2. So I divide this side by 2, and if I divide everything on this side by 2, I have to divide everything on this side by 2 also. So I divide the whole right side by 2 as well. So now what I'm left with is y equals 2 divided by 2 is going to be 1. So that's a negative 1x, because if I divide a negative and a positive, then you get a negative answer. That's 7th grade stuff also. And then 4 divided by 2 is a positive 2. So this is what my equation is in slope-intercept form. Y equals mx plus b. Now it is going to be more mathematical. You learned back in 6th grade that if there's nothing, or if there's just a 1 in front of the x, you don't have to write it. So what you would prefer, what high school teachers would prefer to see is y equals negative x plus 2. But just know that either one of these I would accept as a correct answer. Both are correct, but this is how your high schoolers teachers are going to want to see it. Alright, so let's move on to the next one. Let me get me a line here to separate. Alright, and I'm going to go a little bit faster on this next one because they're all done the same. So we've got negative 4x plus 4y equals 4. And I'm trying to get in the form of y equals mx plus b. So that means I want this guy to go away, the negative 4x's. Well, the opposite of negative 4x's is adding 4x's. So I'm going to add 4x's here. and then I need to add 4x's on this side, and that leaves me with 4y equals 4x plus 4. See, remember, they're not like terms, they have to stay separate. And then I'm going to divide this side by 4 to get y by itself. And I have to divide everything on this side by 4. So now y equals 1x plus 1. Or a more mathematical way to write it is y equals x plus 1. Okay, both are correct. So I'm going to just circle this one because that's how I'd like to see the answer, but if you do it differently, that's okay. Alright, so now let me create another line to separate these. Alright, very last one. We've got negative 4x plus 3y equals negative 12. I'm trying to get in the form of y equals mx plus b. That means this negative 4x needs to go away. So the opposite of subtracting 4x's is adding 4x's. So I'm going to add 4x here. And I'm going to add 4x's here. And so what I'm left with is 3y equals 4x minus 12. I want to get the y by itself, so I want that 3 to go away. The opposite of multiplying a 3 is dividing a 3. So I divide this side by 3 and divide this side by 3, or the whole side by 3, everything. So now I've got y equals 4/3 x minus 12 divided by 3 is 4. Now I want to point this out. You guys are probably used to turning that into a mixed number because that's an improper fraction. I'm going to leave it as an improper fraction for right now, and I'll tell you why. Lots of times when we're putting things in a slope-intercept form, we're going to have to be graphing it fairly soon, and we are going to end up graphing this, and we want it in a fraction because you remember this is my rise and this is my run. So I told the kids it's okay if you leave that as a fraction. In fact, I'd prefer it because we're going to end up graphing that on a coordinate plane. But this is how you do numbers 1 through 3.